Today, I've got some exciting and somewhat concerning news about space travel and its effects on the human body, especially concerning Mars missions. How could these journeys potentially cause permanent damage to our kidneys, bones, heart, and vision? Let's dive into this fascinating topic together. For a long time, scientists have been researching the effects of space travel on human health. But recent findings suggest that trips to Mars could pose serious health risks. This discovery is a big warning for future space missions. So it's important to delve deeper into this subject and understand it thoroughly. Today, I'll share detailed information, research, historical context, and expert opinions on this topic. First, to understand the effects of space travel on the human body, we need to go back in time a bit. Since the 1970s, we've known that leaving Earth's magnetic field can cause damage to the body. But what is this magnetic field, and why is it so important? Earth's magnetic field protects us from solar winds and galactic cosmic radiation. Without this protective shield, astronauts can suffer from bone density loss, weakening of the heart and eyes, and kidney stone formation. Earth's magnetic field is crucial for life on our planet. It acts like a shield, protecting us from harmful cosmic radiation. Solar winds and galactic cosmic radiation are high-energy particles that float freely in space and can be very harmful to living organisms. Without our magnetic field, these particles could reach the surface of our planet directly, affecting all life here. The 1960s and 1970s marked the beginning of human space travel. The first astronauts experienced firsthand the effects of leaving Earth's magnetic field on their bodies. Research from that era showed that space travel could have some negative effects on human health. Long-term space missions could lead to significant bone density loss, muscle wasting, cardiovascular issues, and a weakened immune system. However, at that time, we didn't fully understand how severe these effects were or what long-term consequences they might have. Therefore, space agencies and scientists have worked intensely to study this topic further and develop measures to protect astronauts' health. Now, let's fast forward to the present and look at the new findings. We still don't have enough information about the long-term damage caused by space travel. To fill this gap, researchers from over 40 institutions conducted the most comprehensive study to date on how space travel affects the kidneys and other organs. They analyzed data from at least 40 human and mouse missions to low Earth orbit, as well as simulations with mice and rats. In these simulations, animals were exposed to levels of galactic cosmic radiation similar to those during Mars missions for periods of 1.5 to 2.5 years. The results showed that mice exposed to 2.5 years of radiation sustained permanent kidney damage and decreased organ function. Additionally, it was found that astronauts could suffer from bone density loss, weakened heart function, and impaired vision. These findings pose serious risks for astronauts planning a 3-year round trip to Mars. Dr. Siew, the lead author of the study published in the peer-reviewed journal Nature Communications, emphasized, "If we don't develop new ways to protect kidneys, an astronaut might be able to get to Mars but need dialysis on the way back." He also pointed out that space travel can lead to significant bone density loss and weakened heart function. Dr. Siew added, "We know that the symptoms of radiation damage to the kidneys show up late. By the time they appear, it might be too late to prevent kidney failure, which would be catastrophic for the mission's success." Bone density loss is one of the most common and serious effects of space travel. On Earth, gravity helps keep our bones strong. But in space without gravity, our bones lose this support and gradually weaken. Long-term space missions can lead to significant reductions in bone density, causing serious health issues when astronauts return to Earth. Bone density loss is particularly concerning for long-term Mars missions. A round trip to Mars will take about 3 years, and during this time, astronauts will be in a zero-gravity environment. This could result in substantial bone density loss, severely affecting their health on Mars and upon their return to Earth. Heart health is another critical area affected by space travel. On Earth, gravity aids in the circulation of blood throughout our bodies, but in space, without gravity, the heart's job becomes much harder. Long-term space missions can lead to weakened heart muscles and decreased cardiovascular function. This is also a significant concern for Mars missions. Deteriorating heart health could hinder astronauts' ability to perform their tasks and cause serious health problems when they return. Therefore, space agencies and scientists are working to develop various measures and treatments to protect astronauts' heart health. Another major impact of space travel is on vision. In space, without gravity, fluids in the eyes behave differently, which can impair vision. Long-term space missions can cause permanent vision problems for astronauts, a major concern for Mars missions. Impaired vision can make it difficult for astronauts to perform their tasks and lead to severe health issues when they return. Therefore, space agencies and scientists are striving to develop measures and treatments to protect astronauts' vision. And of course, kidney health. Our kidneys are crucial for filtering waste products and excess fluids from our bodies. In space, exposure to radiation can cause permanent damage to our kidneys. This damage can lead to decreased kidney function and kidney failure. A 3-year round trip to Mars could be extremely dangerous for the kidneys. Kidney health is vital for overall health and well-being, and any damage can have severe consequences. Hence, understanding and mitigating the risks to kidney health is crucial for the success of long-term space missions. To date, only 24 people have ventured beyond Earth's magnetic shield, experiencing galactic cosmic radiation for 6 to 12 days. However, organizations like NASA and SpaceX are planning longer missions to Mars, which require measures to protect astronauts' health. Researchers believe that developing medications for astronauts could also benefit other fields, such as helping cancer patients' kidneys withstand more radiation. Space is one of humanity's greatest frontiers, but understanding and minimizing the health effects of these journeys is essential. Mars missions will test not only our technological limits, but also our biological boundaries. Therefore, the work of scientists in this area is of utmost importance. Space is one of humanity's greatest adventures. However, we need more research to understand the effects of these journeys on our health and to minimize these effects. Mars missions will test not only our technological, but also our biological boundaries. Thus, the research being conducted by scientists in this field is of paramount importance. If you're interested in seeing more content about space and science, don't forget to subscribe to our channel. See you in the next video, and until then, take care.